So today we're going to prove the quadratic equation, and here we have the quadratic equation where a cannot be 0, because if we insert a 0 on a's place, it would not be a quadratic equation, it would be a linear function or equation, as we can see here. And a, b, c are all numbers, and d is the discriminant, and we can see here our solution formula and our discriminant formula that we will use later on. We want to get to our solution by reducing on a formula up here, and we will also, like in the heat of it all, use the discriminant function as well to define the solutions for the quadratic equation. So first of all, up here we have our quadratic equation, and since we want to start out by finding d, we will add 4a. We already have the c. We can see over here in our discriminant formula that we have 4a, c, so we want to have that. So we will add 4a on both sides, like so. And this just equals 0, and we will just, multiply. We will multiply into the parentheses, exactly. And this will be and now we can see that we have our 4ac over here, which we wanted to find in the beginning. And now the next step, we will subtract 4ac to the other side, and we will now do that. And we're doing this in order to find d as well. And we have that here. Now we'll add b squared to our equation as well, because we also, it is in the discriminant formula. And we will do so. And we'll just put our b squared in here, because that will make it look more like the discriminant formula over here. And we can now see that we have found d, because this section right here is the same as this section over here in our discriminant formula. So we can say that this is the same as d. And now where we have this, we will use our rule of the first identity on this bit right here. In order to do that, we will have to rewrite this a little bit. So instead we'll go 2 squared times a squared times x squared. And this, instead of writing 4, we'll say 2 times a b times, it's actually easier if we also write like 2 here, right there. And then we write times x times b. I think that's how it is supposed to be. Plus b squared is equal to d. And now we can write it as our first identity. So what we know now is that this section right here is a, that this section right here is our 2ab, and that this section right here is our b. And we can see that this is our 2ab, because if we look at it, we know that we need to have like 2 of a, which is like 2ax, which we have here, and then the b is the b right there, 2b. So that's how we can understand it. And now we'll put it inside the parentheses. So we know that we have to write a plus b in the parentheses squared. So first the a is 2ax, and then plus, and b is our b, which will be squared. And then that is sort of this bit written down a lot easier. It's the same as d. And now we'll find the quadratic root of this, and we'll do that like so. Right there. And then I will continue our proof. And now we've also added a parenthesis here and a squared here, since it's this that we want to find the quadratic root of. And we can see that, of course, the square parenthesis cancels out the square root sign here, and we're left with, I'll write it over here now, like so. And now we just want to isolate x, and we'll do that by first subtracting b on both sides. And we'll do it like this. And then we need to like add the plus minus, because with the quadratic rule we can do both. And then we will now be left with this. And we're really close to getting our solution from our table over there. Now we'll just divide by 2a on both sides to isolate x, like so. And we can see from that that we are left with this. Which is our solutions formula from the other table.